my dear student. In this class, I'm going to solve some MCQ question on the basis of chapter number 11 in physics part. The name of the chapter is Current Electricity, and my today's topic to solve some MCQ or objective type question including our syllabus. Boys and girls, in the board there are some board questions given. The different types of some board question is given here. In first board question, we see how much is the value of I in the current in a circuit. I repeat, how much is the value of I in the circuit. Boys and girls, this circuit is a board question. This board question is appeared in Dhaka board 2019. You see, boys and girls, there is a battery or cell here. The electromotive force of this battery is 20 volt, and there are two resistors. One is R1 and another is R2. These two are connected in between AB point in a parallel connection, and there are four options given here. One is I equal to half ampere, B I equal to 2 ampere, C I equal to 4 ampere, and D I equal to 8 ampere. And before find out the total circuit current, I need to find out at first the equivalent resistance of this circuit. So the equivalent resistance R will equal to, in this case, 1 by R1, 1 by R1 plus here 1 by R2. Here R1 and R2 both are equal, and there is 5 ampere. And if I consider this 5 ampere as a connected in parallel connection, then I can say total equivalent resistance is here 2.5 ohm. And then circuit current I will equal to E divided by R. So E equal to here 20, E equal to here 20, and R equal to here 2.5. So this is 8 ampere. 8 ampere. Now it is very clear that the total circuit current is equal to here 8 ampere. So this is 8 ampere. So 8 ampere current flows through this circuit or this device. For second question, question number 2, that is 1 kilowatt hour will equal to how much joule? I repeat, 1 kilowatt hour will equal to how much joule? Girls, I already solved here question number A. So I have to erase this question number A so that I can use this space to give you the solution of the other question or rest of the other questions here. So for that target, I'm going to erase this question number A space. It's occupied by question number A. Okay, yes, completed. In this segment, 1 kilowatt hour. 1 kilowatt hour will equal to, you see, 1 kilowatt. Kilo is what? How much? This is 1000 watt. And 1 watt will equal to 1 joule per second. So 1000 joule per second. And if you convert 1 hour into second, then you see that this will gives you 3600 second time. So for this statement here, second and second will cancel out. So total part is here 3600, and then including this 000 joule. If you convert this number into scientific conversion of number, then you see this becomes 3.6 into 10 to the power. You have to give a decimal sign at this particular point. You want to give a decimal sign after just 3. So when you give decimal sign after just 3, okay, then you see the rest number are 1, 2, 3, 4, 5, 6. There are 6 number here. That's why 10 to the power 6 joule. So 1 kilowatt hour will equal to how much joule? That is 3.6 into 10 to the power 6 joule. And I think the correct answer is question number B. You see, boys and girls, this is also a board question, and this question, this board question is appeared at Joshua board 19, and the answer is option B, 3.6 into 10 to the power 6 joule. 3.6 into 10 to the power 6 joule. Okay. Now I'm going to solve question number 3. This is also one question. Now R1, R2 resistance. The value of R1 is 2 ohm and the value of R2 is 8 ohm. And these R1 and R2 are connected in parallel connection. Because if you point here at point A, give point here at point B, then see in between point A and point B, a current IU divides into 2 parts. You may consider here one is I1 and another is here I2. Since one is here I1 and another is here I2, then you can say that here I1 and I2 current divides. So since current divides, that's why R1 and R2 are connected in here parallel connection. R1 and R2 are connected here in parallel connection with electromotive force or battery E. I repeat, with electromotive force or battery here E. Okay, then you are going to find out the total power of this circuit. Calculate the power of this circuit. So you are going to find out the total power. So before find out total power, I'm going to find out the equivalent resistance of the circuit. So RP will equal to 1 by R1 plus 1 by R2. From this we can see that R1 into R2 divided by R1 plus R2. R1 into R2 divided by R1 plus R2. So the total resistance of this part is 8 into 2 divided by 8 plus 2 will equal to 10. So 1.6 ohm. 1.6 ohm. And then we are going to find out, say this R, not RP, this R. And then you are going to find out power of the circuit. So before find out power, you need to know which equation you want to use. Here electromotive force or V or E is given and here R is given. And by considering this V and R, we must choose the correct equation or perfect equation here. You know the equation of power P will equal to W divided by T. So will equal to VI will equal to V square by R will equal to I square R. There are 4 options here. One is W by T. There, so W is given here. So we cannot use this option W by T. In next plot, if I use V into I, then I have to find out the circuit current. So this is also is not a convenient option here. And I think the third one, V square by R, is the most convenient option here, most suitable option here. And third one is not a suitable option. Okay. So electrical power of the circuit P will equal to V square divided by R. V equal to what? V equal to here 2. So 2 square. R equal to here 1.6. So we'll give you 2 square means 4 divided by 1.6. will give you 2.67 ampere. 2.67, sorry, 2.67 watt. 2.67 watt. This is the correct power of the circuit. Now we are going to match this correct answer with my given option. You know, for the case of MCQ part, you need to choose the most correct answer, most closer answer, most appropriate answer. Say the correct answer is here 2.67 watt. 2.67 watt. Is it 0.6 watt? Sorry, 0.4 watt? No, this is the wrong option. And then is it 0.8 watt? No, this is also the wrong option. Is it 1.25 watt? No, this is also the wrong option. Is it 2.5 watt? Most close answer is here 2.5. I repeat, most close answer is here 2.5. That's why in this case 2.5 is the correct answer. It's the most closer answer. It's the most convenient answer. Okay. So electrical power of the circuit is 2.5 watt. What? This one is 2.5 watt. Then I'm going to solve here question number 4. So question number 4. Question number 4. The question number 4 is which one is correct? The following equation is given here, and all of these terms is related to Ohm's law. So the question is which one is correct? This is a question that appeared at Kumila board in 2016. Option A, V equal to I divided by R. Option B, I equal to R by V. Option C, R equal to V by I. Option D, R equal to I by V. And option D, R equal to V by I. You can see that the main equation is V equal to I R. This is the main equation. And all of the equation give you the format just like a divide form. So if you find out V, is it I divided by R? No. V equal to I R. This is correct. So this A number option is not a correct option. This option A is not a correct option here. Okay. And then question number B, if you find out the value of I, then the value of I will equal to V divided by R. That the value of I will equal to V divided by R. But here I equal to R divided by V. I equal to R divided by V. So R divided by V is also a wrong option. Now question number C. If you find out R from this equation, R equal to V divided by I. R equal to V divided by I. So in question number C, there is R equal to I divided by V. R equal to I divided by V. So this is a wrong option. And question number D must be the correct option. That is R equal to V divided by I. Okay? This is a very nice question. And then question number 5. Before starting question number 5, I need to erase the answer of this question number 4 to use this space. Okay? Now, question number 5. Which one of the following objects contain free electrons? I repeat, which one of the following objects contain free electrons? Okay? This is a question that appeared at Dhaka board 2019. Dhaka board 2019, that is last year. Okay. This is a multiple type MCQ question. So, which one of the following objects contain free electron? You know, boys and girls, on the basis of electron theory, matter are divided into three parts. One is conductor, another is semiconductor, and the last one is insulator. So, what is called conductor? The substance which one have free electron and which can conduct electricity, or which can carry electron, is called conductor. So normally metal are conductor, and except metal there are some substance which can carry electron. One is salty water, another is graphite. So this type of matter can carry electron, so those are also called conductor. Now insulator. Insulator means here the substance which cannot carry electron, okay, and which cannot permit electron to pass through. Just like paper, just like wood is a dry wood, just like glass, dry glass, those are insulator. And semiconductor. Semiconductor means under some convenient condition, suitable condition, this type of matter can carry electricity. So to carry electricity, there are some condition here for this semiconductor. You need to give them a suitable condition to permit electricity passing through it. So semiconductor has a very limited number of free electron. The example of semiconductor is silicon, then germanium. Those are the example of semiconductor. Now, I say that the question is again, which of the following objects contain free electron? Okay, now option number A: iron, silver, and platinum. Boys and girls, iron, silver, and platinum. Here iron is a metal, silver is also metal, and platinum is also metal. So those are metal, and you know that metal are a good conductor. All of the metals are good conductor. That's why option number A is correct. This one has free electron. I repeat, this one has free electron. And then option number 2, that is paper, ceramic, oil. You see, boys and girls, paper, dry paper cannot carry electricity because this dry paper doesn't have any free electron. Ceramic cannot conduct electricity, and oil also cannot conduct electricity. Okay, that's why this is not the suitable answer, because those are the insulator here. Those are the insulator here, and because of having insulator, this one cannot carry electricity or cannot carry electron. And then option number 3, copper is a good conductor. Tungsten is a bad conductor, but is a conductor. So tungsten and nichrome, these two are the bad conductor, but these two are the conductor. Okay? These two are the conductor. Okay, so they can carry electricity, they can conduct electricity, and they has some free electron. That's why this is also the correct answer: copper, tungsten, and nichrome. So this is also the correct answer. So from this given information, I can say that the substance which can carry free electron, that is option number A is correct, option 1 is correct, and option 3, that is also correct. So only wrong option is here, option number 2. Now I'm going to solve this part. I'm going to select which one is correct. Number 2 is the wrong option. That's why A is wrong. That's why C is wrong. That's why D is wrong. So the correct answer is here, option number B, 1 and 3. Option number B, 1 and 3, this is a correct option. 1 and 3, this is a correct option. Boys and girls, in next segment, this is a STEM-based MCQ. There is a STEM is given, and this question is appeared at the school board 15, at the school board 15, and On the basis of this circuit, you are going to solve. You are going to solve question number 6 and question number 7. You are going to solve question number 6 and question number 7. Okay. Now, boys and girls, in this circuit there are 3 resistors. One is R1, another is R2, and the last one is R3. R1 is here 1 ohm, R2 is here 3 ohm, R3 is here 5 ohm, and R2 is here 3 ohm. So these are the given resistors, and the electromotive force E will equal to 6 volt. You will equal to 6 volt. You will equal to 6 volt. Okay. Now, on the basis of this system, we are going to solve question number 6 and question number 7. In question number 6, which one is the total current of the circuit? Which one is the total current of the circuit? And there are 4 options here. A is 0.67 ampere, B is 0.76 ampere, C is 9.2 ampere, and D is 10 ampere. So these are the options here, and you want to find out total circuit current of the circuit. Okay, at first I'm going to solve question number C. Question number C. So before solving question number C, I need to find out the equivalent resistance of the circuit. So equivalent resistance of the circuit R will equal to 1 divided by 1 by R1 plus 1 by R2 plus 1 by R3. Boys and girls, 1 divided by 1 by R1 plus 1 by R2 plus here 1 by R3. Okay. Now, put down the value into this equation. 1 by 1 ohm plus 1 by 3 ohm plus 1 by 5 ohm. So, total resistance is here. Total resistance will equal to 0.65 ohm. 0.65 ohm. And then total circuit current I will equal to V divided by R. V equal to 6 volt, R equal to 0.65. So 6 divided by answer will equal to 9.2 ampere. 9.2 ampere. So I got my answer here. Again I repeat, boys and girls, this circuit is given as a STEM based question here. On the basis of this STEM, we are going to solve question number 6 and question number 7. In question number 6, what is the total current of this circuit? The answer is here 9.2 ampere. The answer is here 9.2 ampere. So option number C is the correct option. So option number C is the correct option. You can find out this option very easily. Okay. Now I'm going to solve question number 7. In question number 7, you see which one is the correct equation for equivalent resistance. Which one is correct for equivalent resistance? There are some relation is given here. We're just going to want to know by using this relation how can I find out, how can I reconstruct the circuit. At first, we're going to know about the meaning of this equation, and then I can select which one is correct. So at first, I'm going to give you some information so that you can find out the equation or circuit diagram from this given equation here. Say, on the basis of question number A, option number A, that one is R1 plus R2 parallel R3. R2 parallel of R3. R1 plus R2 parallel of R3. In this section, you see R2 and R3 are connected in parallel, and this part is connected in series with R1. I repeat, R2 and R3 are connected in parallel, and this part are connected in series with R1. So this equation indicates you the circuit diagram is just like this. The circuit diagram is just like this. So this is R2, this is R3, and this one is R1. And then option number B. This option B is R2 plus first bracket R1 plus R3. R1 plus R3. Okay. So, boys and girls, again the same equation and the same relation. So, by using this relation, you see that the circuit diagram is just like this, because no, it's not the same relation here. All of these are adding each other with each other. Okay. So because of adding with each other, all of them are connected in series connection. When you see all of the resistors are connected in just addition or just plus, say R2 plus R1 plus R3. I repeat, boys and girls, R2 plus R1 plus R3. So this indicates you that all of the resistors are connected in series connection. So this is R1, this is R2, and this is R3. Boys and girls, the first one is R1, the second one is R2, and the third one is here R3. So all of these here are connected in series connection, because all of them R2 plus with R1 plus with R3, and these all plus indicate you that those are connected in which connection? Series connection. Now, option number C. In option number C, the relation is here R3 plus R1, and that is parallel with R2. Parallel with R2. So this equation indicates R1 and R2 are parallel. R1 and R2 are parallel. And this parallel connection with a series connection with R3. And this part is connected in series connection with R3. So at first you want to draw R3, this R3, then you need to draw R1 and R2. These are connected in parallel connection. So the first one is R3, second one is R1, third one is R2. So here R1 and R2 are connected in which connection? These two are connected in parallel connection, and this parallel connection stay at a series connection with R3. Now, answer number D indicating R1 parallel with R2, parallel with R3. Next thing, this option will indicate you that R1, R2, and R3. Boys and girls, the equation is given here R1, This R1 is parallel with R2. This R2 is also parallel with R3. So R1, R2, R3 are connected with each other in a parallel connection. Each other in a parallel connection. That's why you can say that. Which one is the correct answer here? Look at the stem. Your stem indicate that R1, R2, R3. R1, R2, R3 are connected in parallel connection. This is boys and girls. R1, R2, R3 are connected in which connection? Parallel connection. Since they are connected in parallel connection, that's why. Can you say that the most correct option is here? Option number D. So number C, the correct answer is here. Option number D. Now, boys and girls, I'm going to close my today's lecture. Before end of my class, I'm going to give you some homework. Your homework is we're going to solve all of the board question. All of the board question, I repeat, all of the board question on the basis of MCQ part. We just focus in this class MCQ part. All of the MCQ part in this chapter. All of the MCQ part in this chapter. Okay? So that's the end of my today's lecture, and also that's the end of this chapter. Chapter number 11 in physics book, and that was current electricity. Thank you very much. Thanks to all. Stay safe.